In this video, I'm going to go over how we use the failure observation engine, otherwise known as FOE, to find an exploitable vulnerability in the Lotus Word Pro document import filter of LibreOffice 3.3.2. We also went ahead and coordinated this issue with the LibreOffice security team, so it has been patched in versions 3.3.3 and 3.4.0 and up. So if you use this application, make sure you're patched up. First thing you want to do is install FOE inside of a virtual machine. You never want to fuzz on your host machine because a lot of bad things can happen. You can get thousands and thousands of temp files spread all over your file system. You might even crash your operating system, so always run FOE inside of a virtual machine. Alright, let's go in configs, examples. I'm going to grab this config file right here and use that as my base. This is a config file that is set up for ImageMagick right now, so I only need to change a few things to get it to work with LibreOffice Writer. I'm going to grab the full path from this desktop shortcut and paste it in right here. I can take off this part at the end because that is specific to ImageMagick. Now to get LibreOffice Writer to fuzz properly, I need to add two command line parameters here. So no logo is going to get rid of the splash screen that pops up every time the application starts, and no restore is going to turn off the document recovery wizard. And for the run ID, this is just going to be the folder name where the crashers go, so you can call that whatever you want. First iteration and last iteration, I'm going to leave that the same. Right now it's set to do 10,000 iterations per seed file. You might want to bump that up depending on how long you want your fuzzing campaign to run. For the seed files directory, I've only got one seed file for this run. This is just a file I found randomly on the internet. There's nothing fancy about it. Crashers are going to go in this output directory. Minimize is equal to true, so it's going to try and minimize all our crashing test cases. I'll go into that a little bit more when we're actually running it. Next thing you're going to need to tweak is the min ratio and max ratio. Usually you'll need to change the max ratio. If it's too high, the file's going to get too mutated, and then when LibreOffice Writer opens it, it's going to not know what to do with it, and it's not even going to parse it. So we're not going to find any bugs in a parser if we're not even launching that code. So I'm going to change the max ratio to make it a little smaller. Next thing I need to tweak is the run timeout. I'm going to set that to 4 seconds. So what that's used for is when LibreOffice Writer is launched, if it's not crashed by the mutated file, then after 4 seconds we just kill it and move on to the next iteration. Next, I'm going to change the debugger timeout. It's usually a good rule of thumb to make that twice as long as your run timeout, because it's got to run the application with the debugger attached, and that's always a little bit slower. And for the debugger, we're using CDB plus Bang exploitable. Bang exploitable is a Microsoft debugger extension that's used to do automated crash analysis and security risk assessments on the crashing test cases that you find. And that's all I need to edit for this config file, so I'm going to go ahead and save that. And let's go ahead and launch FOE. And to do that, you just do fo.py with the config file we just set up. And it's going to go ahead and launch LibreOffice Writer. You can see it opening and closing there. And depending on how mutated the file gets, you might even notice that the file is changing. So on about iteration 7, I'm going to get a crash, so let's just wait for that. Alright, we've got a crash right there, and Bang exploitable thinks it's exploitable. Next thing it's going to do, it's going to start minimizing the crashing test case. Alright, so what it's doing during the minimization is it's trying to figure out the least number of bytes that need to be different and still produce the same crash. So in a lot of cases, it might actually get down to just a 1 byte difference from the seed file. So that helps a lot in crash analysis to try and figure out the cause of the crash. Alright, I'm going to go ahead and kill the fuzz run now. And if I would have let that run, eventually I would have got a directory that kind of looks like this. So I've got folder names with exploitable, probably not exploitable, and unknown. Those are all coming from Bang exploitable. For the Heisenbugs folder, those are crashes that happened with the application, but when the debugger was attached, it did not crash. So in most cases, you can just ignore the Heisenbugs. Then we got a copy of the config file. We got the state file. So this is just the seed file it was on and the iteration it was on. That way you can start where you left off if you need to stop your fuzzing run. Next we have the unique log, and this is just all the unique crashing test cases we found during the fuzz run. And it has a major.minor hash that comes from Bang exploitable, and that's just a hash of the stack. And you should notice that some of these have the same major hash. So what that means is these crashing test cases are most likely pretty similar. They might actually be the same underlying bug, and that's something you want to keep in mind. Just because you have 100 unique crashing test cases, that doesn't mean you have 100 unique underlying bugs. So if we drill down into one of these folders, each crashing test case gets its own folder, and the folder name is just going to be the major.minor hash. And then inside of that, we've got our mutated file. The msec file is the Bang exploitable output. The minimal file is going to be the least number of bytes that are different from the seed file, and then the original file is the original seed file. So let's go ahead and look at the specific crashing test case that we found was exploitable. So first thing we want to do is just look at the Bang exploitable output, and we kind of cruise past all the module loads and get down to the bottom where we have our description. It's going to be read access violation on control flow. Next thing we want to look at is the faulting instruction, and this is a call on EAX +4. So let's find out if we control EAX. If we look at our register values right there, EAX equals the string of bytes. So we need to search in our file if we can find this string of bytes, and then find out if we control it. So let's open up the mutated file in a hex editor, and then let's just do a find for that string of bytes. And we need to switch the endianness, so I'm going to reverse this real quick. 38, 41, 04, 36. And then do a find next. And yep, those bytes are in our file, so I'm going to go ahead and change these to 44, 43, 42, 41. And then save a new file. Next thing we need to do is load this up in the debugger. And these are all the command line parameters that Faux is using when it launches the debugger. We need to launch the debugger the same way Faux does, otherwise we might not get the same crash. And then it just runs Bang exploitable at the end. So let's go ahead and run that. And it takes a couple seconds. Okay, so it looks like we got the same crash. Let's go ahead and look at our registers again. EAX 41, 42, 43, 44. So we obviously control EAX, and since this is a call on EAX, that means we control code flow. And to exploit this, LibreOffice Writer actually uses permanent dep, so we'd have to do return-oriented programming magic to get it to work, but I'm not going to go into that in this video. So I hope you find Faux useful, and thank you for watching.